Hello everyone and welcome to another episode of Solving Advent of Code in Rust and Try to Learn Rust in Between. I am Roberto and we have...
Luciano, hello.
Thank you everyone for following along. If you never did Advent of Code is a code challenge that is published every day at this URL around the Christmas period. We are working toward the last year one, even if there is out the current year one at the moment. There are 24 challenges and you can find them at the URL. We are publishing all our code in a GitHub repository there, and we have a YouTube channel where we publish all the recordings. You can find the link in the description of this Twitch channel. Last time we left part 1, exercise 23. It was not working. We figured out why. We merged a pull request that was fixing that. So basically, Luciano, do you want to share the diff of this pull request? So basically, the idea behind this pull request was we had this array, and we were moving in the array with a point on this array with a pointer, and then we were looking for values, taking them out, and putting them in. And when we were putting them on the left or removing them from the left of the current pointer, the current pointer was supposed to move because this list was circular. So they were capping around, if you read the README. So basically, because of that, all our math with pointer was going crazy. Modulo problems with remembering to increment, decrement. A good approach to simplify all of this was every time you have a game state, the current one is the first element of the array. You do what you have to do with the rest of the array. You put stuff together. Don't worry. When you are done, instead of moving a pointer in the array, you take out the first element and you put that in the back. In the end, you have again your vector or array or whatever that is always with the current element that is the first element of the iterable. And you don't have to take in account if you have overflow at the end or stuff that happened at the beginning and stuff like that. So we remove
your current element is always the first one in the list. You are basically shifting elements rather than moving a cursor.
Exactly. It's less efficient from the memory point of view. We are doing more allocation for sure and everything else. But due to the fact that this vector for part 1 is 10 elements or 9, probably 9 elements, this is not a big deal. What are we doing here is removing some code. We don't have to do all that modulo. We are always removing the element that is the number 1, that is the one after the current one. So current one, the 3 element after, we remove them 3 times, always from 1, because when we take them out, a new one slide in. Then if you scroll a little bit, the logic about all the plus current become very simple. The current value is caps of 0, is always the first one. The caps that are left, the new caps, all you have to work on is all the caps from 1 going on with caps 0 put in the back. Done. And then all the logic is the same as before. The part 1 is I start from a game state that come from the parsing of the input. I do 99 steps because he's asking us what is game 100, but we start already with game 1, so we have just to go 99 steps ahead, and then we return the state result. That state nth 99 is just calling itself 99 times, evolving the game state. Is also returning stuff, but we don't care here about what is returning. We care about what is returning in our tests that are still that are working now. They were not working last episode, and the result is that one. I think there's now another changes or there is some changes in the test. Okay,
the result.
Yeah, the result, because asserting on the vector has the problem that due to the fact that we roll the vector, we have to assert that the vector is any rolled version of the other vector. So we already have a function that is normalizing the array that is result, that is basically giving you the numbers in the right order after the 1. If you see after 1 you have 9, 2, 6, then you go back to the beginning 5, 8, 3, 7, 4, and it is like exactly the number that is in the new line that is 170.
Exactly.
Yeah.
Yeah, because this is highly dependent on how you manage
Yeah,
the data.
it's highly dependent on how you roll this array that is a circle, so is circular by definition. And
Okay,
this time,
maybe I can show very quickly that the tests actually run and everything is working.
yay.
And everything is fine. And we have implemented part 1 and a bunch of other tests just to make sure that our logic is correct.
Yeah. When we merged, Clippy suggested us improvement. Do we want to show?
I'm gonna show you very quickly. It's basically this one. I don't know if it's readable. Maybe.
Okay,
Maybe.
like this is better.
So basically, when you do a for loop with a range, like here we're going for 0 to 2, basically, and we use that I only to index a slice or a vector or whatever is indexable. And then we do that to basically mutate the value at that particular position every time we do an iteration of the loop. It's probably more idiomatic, at least for what Clip is suggesting us, to use an itermut, where basically, if you do that, the current element of the iteration is a mutable reference to the current item. So you could do the reference assignment. I'm not sure it's called that way, but basically you can just assign directly into that particular position without having to reason about an index. So you just get already a pointer for the value that you want to mutate. So this probably more idiomatic for Clippy. We did this change as well.
So now Clippy is happy. Now we have to go on with part 2. Sadly, part 2 is a little bit different. We can read it from part 1.
Yes,
but different
show it again.
Just as size. I mean.
So all of that was part 1. Part 2 is basically saying,
due to what you can only assume in mistranslation, you are quite surprised when the crabs start arranging many cups in a circle on your raft. 1 million, big raft. So now it's not 9 numbers in an array, but it's 1 million numbers. And as you can imagine, we can try to run the code on top of 1 million element, but every time we shift, is going to be crazy, I think.
Yeah, exactly.
And also, we don't have to do 100 moves. We have to do 10 millions moves that are way more.
Yeah, so that basically means that our approach is unfeasible, because that means that every game iteration, and we have to do 10 million of them, we shift millions of items all around.
Yeah, 1 million of items shifted every time we do a loop, and we have to do 10 million loop. Also, the result is no more the sequence of numbers, but is a multiplication between the number after the 1 and the 1 after again. So that is written in the example above.
So you have this value
that is after the 1, and
after the 1. Okay, so in your circular list, I don't think we are visualizing it here anywhere.
Yeah,
but in the
crab
list,
is going to. The crab is going to hide your star on each under the 2 caps that we land immediately clockwise of cap 1. So you have cap 1.
Okay.
You have another 2 caps that are cells arrays, cells of the array. You have a number and another number. You have to take those 2 numbers, multiply them together, get a huge number, and that is the result.
Yes.
That is different from the previous result because it was different in the
different
definition.
Logic. Yeah. So we also need to change that logic.
We have to change size, number of steps, and logic to get the result.
So last time I remember, Roberto, you showed us a potential approach to implement, let's say, a lightweight linked list.
Yes.
That could be used here as a better way to manage memory, so that we don't have to essentially move items around, but we can just move pointers between the next elements.
Yes. If you want, we can talk about it again. So this was one input, basically. This is a linked list, a circular linked list, because the last element is going back to the first one. It due to the fact that we don't have values that are duplicated by definition, by how the input is gave us, we can say that in a vector array, any kind of index can be a map also. Somebody last time suggested that this could be a map. Yes, it's true, but probably an array, being dense, an array is more efficient from memory-wise, I mean.
Also in a map we will need to hash the values, so probably there is a little bit of extra cost every single time.
Instead, if you already have the index, you just go there directly. Here you go 3, go to 2, 2 go to 6, 6 go to 5, 5 go to 1, and so on. 8 at the end go back to 3. Array of 0 is not used because there is no 0 in our array, not even in the part 2. This, when we have the new inputs, will go on with 8 going to 10, 10 going to 11, up to 1 million, and 1 million going all the way back to 3. But again, it's just assigning to an array.
Yeah, let me rephrase that just for me to understand, and I suppose for clarity. Basically, what we are doing is, in this huge array, if we take a position X, the value associated to that position X means this is the next number from X.
Yeah.
So for instance, here, if you take array 3 equal 2, means if you're looking at the number 3, the next value is going to be number 2. Then if you want to know what's the next value from there, you need to go to array 2. You will see that the next value is 6. Then you go to 6 and you see the next value is 5. And this way you basically build in the chain of the linked list.
Yeah, the text say to take 3 numbers out of the list. And we can do this easily here, just changing 2 values. Because we take the one after 3, the one after 2, and the one after 6, that are those 3 numbers. Then we point 3 at 1, and okay, we can also point 5 to 2. This is not mandatory, it's just to have nice lists. So basically, just changing a pointer, just changing a cell, we are able to take out our numbers and return our numbers. Then we also have to find the one number that is smaller than the current one that is in our list. How we do this? This is easy. We take 3, we remove 1, so 3 becomes 2. Is 2 one of the 3 numbers that we removed? Yes. Okay, we can't use 2. We remove 1 again, we get 1. Is 1 one of the 3 numbers that we removed from the list? No. Cool. So our destination number is 1. If we want to go to 0, we have to go and roll back to the highest number, that in our case will be 1 million. So we have to do all the way around because obviously there is no 0. When you have your destination, again, you have to put back the 3 numbers after your destination. How you do this? You change 2 pointers. So again, you access the array in just 2 elements instead of shifting 1 million of them. And let's say the destination will point to the previous head, to what was previously array 3 pointing. So array of 1 points to 2, and array of 5 points to what array of 1 was pointing before, that is 9. In this way, now the current one is the one after 3. Rearranging the stuff, we have this circular list, and from here we go on again with our 10,000, not 1,000, not 10 millions, not 10,000. 10,000 was fast. 10 millions iteration. At the end, we will have a scrambled version of this, and we have to take the 2 numbers that come after 1 and multiply them together.
This is for part 2.
This is part 2,
right.
Yes.
I suppose, it doesn't make sense for now to because once we have this data structure, we could also use it for part 1, but that's an optimization we can do later. For now, let's just try to solve.
Yeah, we can do that later. 2. Also, game state, probably we have to create a game state part 2, because the result is different. The parsing logic is slightly different because we have to also add the numbers up to 1 million.
I don't know. We can probably see, but I will start by creating this data structure for the circular linked list. What do you think?
In a new file, you mean?
Yeah, we can do like a
Yeah,
mini module.
Yes.
So what do we call it?
This is
C list.
Circular linked list. Yes, a list is fine.
Or CLL.
CL list. Cool.
Okay, so now we need to include this file in the main one. So this way, whatever we write in here will be recognized by Rust Analyzer. So let's call it, let's do a struct CLL list. And what do we put inside? Data, I guess.
Yeah, our data is an array or a vector of 1 million elements. Can we create an array that big in Rust, or is Stack Overflowing?
So if we create it as an array like this, I think we will need to box it to force it to be allocated in the heap. So something like this, box of whatever. What are we using? USides? I'm not sure. What is that?
If USides can contain 1 million, is fine.
But we put U64 just to be sure.
With U64, we are sure for sure. And it will be 1,000,001 element because
there is 0 as well to be considered. Right?
We don't use 0, but we have to allocate memory for it.
So yeah, we have an n that either we write it now explicitly, like we know it's 1 million. What is it? Another 0. So
1,000,001 because we have to.
1.
Okay. We can create the n later. I mean, can we hard-code it for now and then?
Yeah, we can make it generic with a const generic there.
In the chat, they say that I32 is going up to 2 billions. It's true, but then we have to multiply them together, and using 32-bit, we can overflow the multiplication. Depends on the numbers, obviously. But it could. We can always cast later. That is also true.
Actually, let's cast later because then we will save a lot of memory, right? If we use U32.
Okay, we can cast when we have the result.
Because we are creating 1 million elements, so let's be efficient there. Okay, so now the interesting bit is if we implement CLL list, let's try to define the operations that we want to do based on the game.
We have to create it, so it has to ingest. Do you want to do the parsing in the game logic? So here here we have as input the input already parsed. In your opinion? Okay, so we have to create a new.
Yeah, we can do just for simplicity. We can say that new takes a
can
box.
Take an iterator.
We could also do an iterator, and at that point we can implement a from iterator. Actually, let's do that because I think it's interesting. What we can do is implement from iterator for CLL list. And from iterator is basically a trait that is actually something we have been using all the time, because every time we do .collect, that collect exists only if the struct you are trying to collect into has a from iterator implemented. So if we implement this trait, that basically means that whatever iterator we have, then we can collect into a CLL list. And the only thing that we need to specify is that from iterator needs to have a type, and the type in this case is U32. So it's the type of the elements that we are trying to collect from. So that becomes U32. And at this point, we have an iterator here, and we can define how to use an iterator to create the CLL list. which I think is going to be interesting, because I'm wondering if it just makes sense to use a vec rather than a boxed slice. Maybe it's just easier.
Basically, the idea was from the iterator, the first element of the iterator go in cell 1, not 2, not 0, because we are skipping 0, and so on. So I don't know if you can do iterator enumerate and then use the index and the index plus 1 and the value in our data.
Okay, so what we could do is do the following. We create let mute data, and we do basically what we do is this with 0 U32 1 million times, 1,000,001, and then we do into box sliced. I think there is, wasn't it? I thought that there was like an into box sliced.
No.
Maybe I remember wrong. Because if we do this, I think this might explode straight away.
With a Stack Overflow?
We can probably test it.
Yeah.
Because then at the end of the day, what we want to return is we will use the iterator here to populate all the values that are in the iterator in order. And then at the end, we return basically CLL list with data.
Yes, that was the idea.
Which now it doesn't like it because it's not a box from... Now, of course, it's telling us this doesn't have to be mutable because we are not mutating, you're not using the iterator, but let's create some tests. So CFG tests, I think. Then mod tests. And then test FN test. And what we want to do is basically say, just trying to create a random iterator. So we can just say, I don't know, let mute, let data equal, I don't know, 1, 2, 3, 4, 5, 6. And that needs to be, they need to be U32. So we'll need to say U32 of size, whatever. Should be able to infer the size. And then we say
data.collect, no, data.iter.collect.
So we'll let list CLL list equal data.iter.collect. And we can check if it explodes or not. Why code is inactive? This is how many elements? 6, right?
And
did I spell the test correct? Let me see, because I can never remember. Oh, it's test singular. Okay. Thank you.
Okay.
Now we need to use super asterisk. Oh, thank you, Amperl, for suggesting it in the chat, but I was not watching.
Sorry, I was distracted too.
Now, okay, cannot be built from an iterator over reference. Okay, that needs to be into iter. And now it's happy. And if we run this test, it is exploding because as overflowed is stuck. So yes, we cannot just do this. How do we do it? There was something like into box sliced. Let me search for it. If nobody remembers in the chat, I'm gonna search for it.
Wasn't it on vectors? Because here, those are array. Into box sliced is not for vectors.
It could be, I suppose.
So you can't allocate an array in the heap, or can you?
So what we could do is probably just do a vec at this point, right? A vec of U32, and we can create it with capacity 1,000,001.
Okay.
So we can do vec with capacity is, and I think now we can do into box slices into, yeah, that's the one we wanted. And at this point, I think we don't even need this. This would be already.
Do we have to change the type on line 2
it?
or not?
Oh yeah, because now it's just U32. Okay, that's actually better because now we can keep it more generalized. Yeah, and it will depend from the iterator. Okay. I'm not sure that's the best design, but we could come back to it.
Yeah. So now we have to take the iterator in line 8 and
Yeah, now if we run this test, it should work.
so it should not crash badly. Okay, yeah.
Perfect. Okay. So next step is, let's very quickly do debug because we might need this just to test things around. But the next pieces of functionality we want to implement here is actually to populate
Yes.
the value, right?
Mhm.
So what we do is for
Just a second. Can't we? Sorry, I'm thinking. Is competence of this class to create the linked list? Probably yes. So if we give as input our input from the test, that is, I don't remember, plus all the numbers 10 to 1 million, we can already say this cell go to this other cell, this cell go to this other cell, and so on, right? So we can iterate over our iterator with a window of 2, with a slice window of 2, and say that the first array is called data. The data of the first element equals second element, and then move this window around.
yes. Yeah, that sounds interesting. But
how you do that?
You will get just an iterator, and data is what we need to fill.
Yeah.
So okay, one way we can do that is to do. I've seen this was actually the first advent of code of this year. There was something similar. So I've seen a bunch of different approaches to this problem to do like windowed iterators. One approach is to use a library called itertools, which allows you to actually do windows. Another one, if you have a vector, there is literally a method called .window, but here we have a generic iterator, so we don't have that. Another approach I've seen is that we can do iter.pickable, I think.
Picktuple?
Pickable? No? No. Maybe that works only for particular types of iterators. The next one I've seen is basically you do let iter2 equal iter.clone.
Okay, and then you go, okay.
Then you say let iter2 dot skip one, and then you can build a zip of 2 iterators. So you do iter.zip. I don't know why it doesn't like.
It's complaining about iter up there, but I think the type is fine.
I think it was just that we were not using it.
Okay, don't know. So in this way, we have the 2 elements with this iterator. And now we need to do something with both of them.
Exactly. Now what we will do is for, I don't know, first, second in this. And probably we also want to enumerate, so we know the position.
No, it's enough to do data of first equals second.
Right, yes, so we can do this. You're right, that's probably more than enough.
And to make it circular, we have to take, because going first and second, we are going through. When we are at the end, we have to do the last one of the first iterator with the first one of the second iterator. So we have to do the close the circle.
Yes, so we need to do data 0 equals 0 just to... I mean, that's already done because that's the default, right? So we don't.
Yeah, but we are not going to touch
the last one.
Data of last one equal the value of the first one of the iterator. That how can we? Well, we can keep it from iter 2. When we skip in iter 2, can we also get the first element instead of skipping it?
Right. So we could do
let first equal.
Let first equal next unwrap, I suppose. And that's making it move, so we can do first.
Yeah, this way we closed the circular list.
I don't know why it's not being happy with this. Parameter t.
Yeah, but t is declared as an iterator.
Yeah. Doesn't mean that you need to do iter. Okay, you'll need to do the iter explicitly, I think. But then it's not necessarily clonable. So this approach doesn't work.
Also, why is
Can we use peek? Peekable? Okay, we can use peekable.
I don't know what it does.
So peekable, I think it keeps the next one available. So it probably looks one forward for you. And rather than just doing next and consuming it, you can also call .peek to just look at the next one.
Okay.
So we could use only one iterator and then use peek to get the next one. So we can probably do this. Okay. So let's see. What do we want to do? If we use peekable, then what we can do is basically this for first in all of this. And basically second, actually, let's do, we need to save this. We need to say, sorry, I'm making a mess. I'll try to explain in a second.
Or do you have also to change the name, or you can shadow the name of the parameter?
We can shadow it. I'm not particularly worried. The only thing is that now, how do we keep the first forever?
Again,
for this one too.
Here in this solution, when we arrive at the last element, we pick the next one, we fail because there is no next one. But when we fail at picking the next element, we have to put in the first one. The first one. The first.
Yes, but we need to save it somehow.
Yes.
Oh yeah, we can use peek as well. Of course.
Before starting.
Let first equal iter.peek. So that will give us the first one without consuming it. And now,
okay,
let's call them A and B, I suppose.
Yes, because we are shadowing all the names.
Okay, now this unwrap might fail if we are at the very last one. So we need to do, I suppose, if let
B equal some.
B equal
some iter_peek. Iter_peek.
No, sorry, it's like this.
No?
If let some
if let some be, my God, sorry, this syntax
is equal
not,
all of that.
This syntax is not getting in my mind yet.
And if that's the case, what we do is basically data A equal B.
B else if we don't have it.
B is
B,
giving
B.
us a reference, so probably we'll need to do the reference.
Okay.
And A, why doesn't like it? Oh, because yeah, of course, we need to have items as USIDs.
Everything is a
yeah. Let's
rename
put
everything.
everything as USIDs just to make our
USIDs.
life easier. Okay, and now this first one, why doesn't like it? Because this is an option, but in this case we can unwrap safely because we know
because
there is
at least we need one element. In the else of that if, you can remove the line 19. Line 19, you can put it in the else of that if that is in line 14.
in the else of this
If
one,
there
you want
is
to move this one here?
Yeah, and you can use A instead of 1 million.
And you can use A. Wait, but are we saying that we are gonna create an iterator with all the numbers, including the ones after the input?
Yes.
Because the input is just a few numbers.
Yeah.
Then we'll need to start counting.
We start
from
with
there
all
to
the
1
other.
million.
Yeah. So then you can put A because we know that the last one will be that one.
Okay. If that's the assumption, yes. Now, why is it complaining here? Iter moved into iter.
Rename that iter in line 10 because I think is you are shadowing the parameter. I don't know if he's happy about.
I don't think that's the problem.
No?
I think once we say pickable, we'll need to use it in one go.
No, I was just suggesting of changing the name of the variable in line 10.
Yeah, let's try. But if we say iter2, right? I think it's still gonna complain for the same reason. That's interesting.
It's complaining in line 11 for something. What? Why line 11 is complaining? No, it's not complaining anymore, but probably was.
It is complaining here. It's saying that we cannot borrow iter2 because it needs to be mutable.
Because we go through it.
That's one problem. Then iter2 here, it gets moved in line 11. Consider borrowing, okay.
In line 11, got to the peak is consuming the iterator.
Okay, now first, what is it? Found a double reference. Oh my god. And it's still complaining. Yeah, I think we're still moving.
Put brackets in line 11 when you do the reference. In line 11.
Podge online.
Hello,
Podge.
In line 11, when you do iter2 with the end together, put a round brackets around it because I think with the reference inside the round brackets.
You think?
I'm just throwing an hypothesis. Not around everything. Close it after the 2.
After this.
Yeah.
Okay, that might do the trick. Cannot be the referenced.
Okay, now it's just one reference.
And now we're back to it. Okay, you know what? What if we just do, rather than using from iterator, we just do our own new where we pass a vector?
Yeah, perfect.
And just use that.
We have to do this outside at this point. I don't know what's happening outside when we'll do this at this point, but okay, let's pass it in. We have to do this somewhere, inside or outside.
Oh yeah, we'll need to do it anyway. Right?
Somewhere you have to do this. Going through the window with a slice of 2 and doing stuff. We can do the dirty way and just access the cds.data and working directly on the data. For me, it's fine. Let's do that. Come on. Let's not even create a new at this point.
But then we still need to figure out this problem because we will still have an iterator over the original data, right?
Over the original input, when we slice into single numbers, we have to put them inside the data somehow, and we have to go in windows on top of that, window for width 2 on top of them. In any case, at one point we have to do that.
Okay, now I'm wondering if there is a better way to do this. Because this one is complaining cannot borrow data in cannot borrow as mutable. Oh, does it need to be this? Okay, and then here is still moved, and it's moved where? Borrow of either 2 occurs here. Borrow later used.
Okay,
17.
so okay, so again we can't.
Can we just say again this? No, right? More than once. Oh, you know what? I know what we can do.
Dot iter? No.
Dot on. Because I mean, this is just one value.
Are we cloning the usides? Okay. Yeah, with one value, why not?
And I think when with the reference there, we will clone anyway.
Mm-hmm.
Okay, now this either to pick moved where? Because we did into either.
Try to do again the trick that you did in line 11. Open brackets and mute iter2 close brackets dot pick. No. Okay, sorry.
I think it doesn't like it because
when we call into iter, where do we call into iter?
Okay, the other approach is that we use itertools, which makes this super simple. We install the library itertools and we use that approach.
We can also do a numeric approach, but I'm not understanding why it's so hard to just have to start the tool.
I'll vote for itertools.
Okay, let's install it.
So we can do cd year 2020
23.
exercise 23 cargo add itertools. Thank you. And now what we can do with itertools, let me try to find the documentation. I think we have it here. Come on. Why? Get smaller.
Are you fighting with all your multi-desktops?
Yes. Okay, so this one should have something that allows us to do like windows. Tuple windows. I think this is the one I was using before.
Mm-hmm.
And it allows us to basically say, yeah, when you do .next, depending on how many items you're trying to get, you will get like a window of those items.
Okay. But this window is not circular. So when you get the last one, you will not get it in pair with the first one. We have to do that on our own.
So basically, if we do this, we use iter_tools because this is how you enable the additional functionality. In this iterator, we can do this. So we need to keep the first one anyway. So maybe we just keep this one. But here what we can do, yeah, I'm not sure how to keep the first one. But other than that, what we could do, let's comment this one out for a second.
Yeah,
It's basically iter dot win into iterable window tuple windows, and basically here we can just say A and B,
and it will give us a tuple of size 2. Okay, because of
and then at that point we can just do this
without the star, because we don't have to reference anything at this point. Yeah. Plus, we always have to do the last one that go to the first one, because we are circular.
Yes, which is the tricky bit that we have to figure out. I suppose one way of doing this could be if we do, this is super ugly. I'm trying to think iter, if there is, we cannot clone. So if we do iter2, a clonable.
They were suggesting to add a circular tuple window. Is there already? They added it?
Yeah, this is not clonable. Okay, let's see if there is a circular
tuple window. Circular underline tuple underline window.
There is one, yeah. But
Yeah.
how do we know when to stop?
Know when to stop. See, it's just one more element that is the last one that go to the first one. Is what we want. See the example when there is the first assert, sixth line. Assert equal vector 1, 2, 2, 3, 4, 4, 3, 4, 4, 1, and then it stops.
But it stops because no, they are still calling next, so you get none. Okay, perfect. That's what we want. Awesome.
That's what we want.
Okay, so we want this, and
okay, now why is complaining?
Let's delete everything. Wait, what? Oh, because they have the same problem. They need to clone, and that iterator is not clonable. So this is probably something like this, but if we do that, I think it's going to complain.
So now we are saying that you want to traits into iterable and clonable.
Yeah. Let me try if this works. Still doesn't like it. So into iter.
The trait clone is not implemented for into iter. Yeah. Cool. I'm fine with it.
You know what? If we do this. So we don't use the standard trait. So we are not going to be able to use collect. We need to call from iter directly.
Okay, for me it's fine. Now what is complaining about? Saying this must be also clonable.
I think, can we do plus clone? Exit size iterator. Oh, it needs to implement also this exit size iterator.
This is start to get complicated. Sorry, I thought it was easier like this.
Yeah, we can try this and see what happens. I'm not really sure. This is the most amazing approach. Anyway, yeah, this is getting more complicated than we want. Cool. So at this point, what do we have? We should be able to load the list. Now this collect doesn't work anymore. What we can do is CLL list from.
It's not colon.
Make it public.
Ah, okay.
It's column anyway. Yeah. From iterator.
Data.
And the iterator is data.iter. Like it. Oh, because this is a slice of view sides, and if found, we need into iter. Okay, so this list should be that, and now I just want to do
debug. Okay.
Len of list, which is going to be massive.
Well, no, because we are just on passing in 6 elements.
Oh, there, yes, but I don't know what happens with this capacity. Probably just allocates the capacity but doesn't show it, right?
No idea what it does with the extra capacity.
Let's see.
Semicolon.
It did explode. Index out of bound. The len is 0, but index is 1 and line 13. Line 13.
Question. When you use vector with capacity, can you do vector of 1 equal this if you never grow the vector to that size?
I think so.
Seems not. So we have to push.
Then what's the point of the capacity?
To allocate the memory ready for that, but your vector is still of length 0 at the beginning. Do a dirty trick. Line 11. Do a 4. 0.
Or we do that into boxed slice. Is that going to allocate all of it?
No idea.
Or we can do entry or default. I think it's another option.
Okay, entry or default, but that's not for the maps.
Now this is gonna give us what? Okay. And now data is just data. Let's see if that is already smarter. Probably not. No, same problem. So what if we do data
Push
an entry?
Do we want to push data in it? Because if we start pushing at 0 and then we overwrite it, it's fine.
How is it? Is it push? No, because now we have
a box. No, you can't push in a box.
Yeah, let's remove this one.
It wrote
this
random
one
start.
does it have an entry? No.
Push.
So we can push. Now what do we push?
Push at 0.
For every item we push at 0. Okay, fair enough.
Yeah, line after remove the data dot that was added because I don't know what happened.
Oh yeah. Good catch.
Again, do another data push outside of the loop before the loop. This is ugly, guys. Before the loop, a data push 0. Try now. Now it will be.
Why do we need this extra one?
Because we don't use the cell 0.
Right. Okay. And now we need to do again data dot into box blah blah blah. Cool. Oh my god, cool.
Okay.
Perfect. Now we can go back to our logic. The next thing that we want is to the next method. So
Yeah, we
if
can
have-
we can also write a test, but okay, let's go on. Next, okay, yes. Next, give us basically data of that value.
and you need to specify
Yeah,
the
you need
I.
yeah, that is a usize because we
It's
have
a usize, yes.
we have everything as usize right now.
And then what we return is basically self.data I.
Yeah, nothing more, nothing
And
less.
that's pretty much it. Up fn, yes. And now we can probably test this one as well. We can assert equal that list.next of, I don't know, let's say 3 is 4.
Yeah.
Yes, and we can also assert the most important one, that next of 6 is 1.
Is 1. I hope that this is working.
Cool. So up to this point is working.
Okay, now we can implement extract free values.
Mm-hmm. So pub fn, what do we call it? Pop
free values. Pop free is
after,
enough
because we want to pop after a certain point.
Again,
right?
self and I as usize.
Now this needs a mutable self, I think, because we'll change the data. And then an I as usize. And then this returns 3 items of usize. So usize 3. Right?
Yes.
So we can create, let's say, usize
You can't
3
do
equals 0, 3.
And return it.
And that's what we return. And now what we want to do is basically let 1 is equal to
self next of I.
Next of I.
It's not with the round bracket. Sorry.
Yeah, you're right. You're right. Sorry. I don't know how is that working. Can you index a usize? Okay, actually,
2 is the self next of 1. Is the self next of 1, and 3 is the self next of 2. If we want to implement something smarter, we can do that later. You wrote next instead of next.
Okay.
Now values
actually.
Oh, you don't need the mutable. You can return an array.
I think we can just return this.
1, 2, 3.
1, 2, 3.
We have to remember to rearrange the pointers. Because now self
now we
data
also need
of I.
4.
Yeah.
Right?
Yes. We need the one after again. It is self next 3.
Next 3. And basically what we need to do is point the I to 4.
Exactly.
So we need to say data self
data I equal 4. Probably we can avoid to have 4 as a variable. You can say self data I equal next self next 3. Yeah, directly.
Actually, yeah.
It's not needed to have a temporary variable for that.
Mm-hmm.
Okay,
so that allows us to easily say, if I give you one number, extract the next 3 items and connect basically the bridge
and we can test this with our small data set because we have 6 elements. So
yes,
we can
if we do
data dot pop 3
equal of list pop 3 after
2,
for instance.
Yeah,
and
is
that
3, 4, and 5.
Be,
3, 4, 5.
3, 4, and 5.
And we assert that the next after 2 is a 6.
list.next after 2 now needs to be 6.
I hope this is working. Now it's
Oh yeah, we need to make the list mutable.
Yeah, right.
Perfect. Okay, so that's very useful. And now the next thing we need to do
is insert.
Is push 3 after, right?
Push 3 after, yes.
Pub fn push 3 after. And again, we need a mutable self, we need I, usides, and this is gonna return nothing.
Nothing. It's working.
So here what we
no, you need also the 3 elements somehow.
Yes, the 3 like this. We can probably use.
Yeah, we use the same data type because it's what we get from the pop. We do our stuff and we put that in the.
Okay. So basically, the first thing that we need to do is to take I and the next, disconnect them. So we need to remember what's the target.
The next. So okay, we have to remember what is the one after I. So let after I equal to self next I. So we just put it away.
Let target, I'm gonna call it, or next target.
I plus 1. I don't know. Take a name.
Is equal to self
next
I
of
I.
Yeah. Now self data I goes.
Now self data I goes to the first one.
The element of element
0. And then the last
self data of element 2,
which is the last one,
goes to next target that we saved in a temporary variable.
Perfect. Okay. So at this point, we're basically saying if I take something out and I have 3 elements, when I insert them again, I need to disconnect those 2 elements first, stuff the 3 elements in between, and then I need to connect the first part of the bridge and the last part of the bridge.
Yeah.
Sounds good. And we can also test this one here. So we can say assert.
No, we have to call is returning nothing. So we have to list
dot push after
6.
And we push,
I don't know. After the 6
or after the 1.
Oh, after the 1 is fine.
So we push 3 elements which are the same. We can just copy paste these ones.
Yeah.
Right. And now we can assert that the next of 1 is 3 and the next of 5 is 2.
Yeah.
Right. Is next of 1 is
3. And the next of 5 is 2.
And the next of 5 is 2. Let's see. If we did everything correctly, we should have a very good starting point. Perfect.
Okay.
So now we can use this library in our
part
business
2.
logic. Part 2. So the first thing we want to do is to
parse the input like before and having an array of numbers.
Are we still using this state? I don't even remember how it's done. So let me check it very quickly. So this game state.
No, this game state is doing completely different stuff. We can create a game state part 2 that contains.
For now we don't use it.
No, we can create it later probably.
Mm-hmm. We just because here we were doing an iterator basically.
Yeah, we can just is to be able to call nth that we created an iterator. Mm-hmm. Where we can do a 4 on top of 1 million or 10 million loops is enough. Also, we have to implement. Well, I don't care about the result for now. Let's do that without a game state, and then we create the state refactoring later. What do you think?
Yes. I was trying to think, how do we create an iterator? Because that's what we need to create our list. So we'll need to have let iter equal something.
Mm-hmm.
Right? And then we do let mute list equal C list, which probably needs to be imported.
You didn't import it? No, you have to is lowercase. Yeah.
from the submodule. Yeah.
From iter, from that iter.
And now we do from iter and that iter, which now, of course, is not going to work because it's not the right type, but that's what we want to make it work.
Let's start with a
Yeah.
vector.
I know what I forgot. This needs to be public.
Let's start with iter as a vector. Dirty. Let's start as iter is a vector.
As a vector of what?
We have to take input, split by char, convert the char to an integer, and collect a vector.
So input. Chars.
Convert the chars to an integer, so 1 become 1, the char 1 become 1.
Oh yeah, we had this somewhere here in the from string. I'm just gonna copy it because I'm lazy. This one, yeah.
Yeah, okay, we can collect that straightforward.
Yeah, that's perfect. I think that makes sense. So S is
but
input.
we have usize instead of U64. I think the only difference is that one.
We can easily fix that. And usize here.
Yeah. Then before using caps, we have to add all the numbers up to 1 million and 1 million. Sorry. So caps push.
I'm thinking we don't even need to push. We just need to create a range that goes from the length of this one to 1 million and 1, right?
To 1 million.
To 1 million.
Yeah.
So
included.
Remaining
1 million
is equal to
10
caps
dot
len, right? Dot 1 million.
The dot equal. Yeah. Okay. We know that the caps length is
now this one is caps dot iter.
I think it's caps len is 9 or is 10. How it is what is the length? Because we have to do from 10 to 1 million included, and not from 9, because otherwise we are duplicating the 9. So I don't know if caps len is right, or we have to do caps len plus 1.
Caps len plus 1, probably it's plus 1.
Probably plus 1, yeah.
Good catch.
Yeah, it was because otherwise we put the 9 twice, then the 9 will point to itself, and that will be an infinite loop, and we are not going anywhere when we put 9.
Now I thought we could use chain, probably remaining dot iter, I think, or into iter.
Into no. No, into iter was there. Yeah, okay, sorry. And chain is not
like it. Oh, this needs to be into iter as well, because otherwise we get references. Cool. So this is an iterator usize. Now, why you don't like an iterator usize?
Because it's not exact size iterator.
Oh, that window thing is eating again.
Can't you collect in a vector? Then vector is a fixed size.
Yes, I wanted to avoid that because the iterator here is cool that is not allocating. You are just producing the values and they will be allocated here.
Yeah, but the circular guy, we are not able to get the first element, and the circular tuple window want to get the first element. So I don't know. Or we find a way there to get the first element, or we find a way here.
Yeah, let's do the dirty trick of saying I suppose we could do here something like let first is equal to caps
of 0.
Yeah.
And then we pass first to formiter. That is wrong, but I feel dirty.
First, yeah, it is not
and
nice.
Then we go and remove the exact size trait. We add the parameter.
We only need first usize.
Sorry, a moment. I have somebody at the door.
Yeah, no worries. So here we do tuple windows, and then we just need to link the last one. So data. Data
of last that we know is 1 million equal to first.
we know is 1 million because
because we know, but you can take the last B that you saw, or you remember the last B that you saw in that loop. You can do before the loop. You can do last let mute last equals 0, and inside you can say every loop last equal B. And now data of last equal first of last, because B is out of scope here. Yeah, this way.
Let's see if our tests are still passing. Okay, here we need to give the first, which is 1.
1, yeah.
No, doesn't work. Why didn't like it?
Index out of bound. Where is this line?
This is line 19. Let's see what we have in line 19 here.
Our last. Because we have to push also at 0 outside of the loop, because then now the loop is shorter by 1.
So we need to push here again.
And then assign.
This is ugly, but whatever. We'll look at it when everything works. Okay, that works. Good catch. Okay, now we have this list. We need to start to play the game, right?
Yes. Sorry.
I don't even remember the rules of the game, but I think we can quickly review them. We just need to do like 10 million simulations or something like that, right?
Yeah, we have to start with a pointer at the first element. We have to take the free element after that pointer, take them out, find the destination that is, if we have a free, is a 2. If the 2 is not in the remaining list, we have to look for a 1. If 1 is not in the remaining list, we have to look for 9, in our case 1 million, because we have to roll to 1 million. When we find it, we have to put back the free elements there, and we have to do this 10 million times. So we have all the primitives are there. We have our mutable list. We just have to do 10 million time minus 1
for
minus,
in 0 to 10 million. Right?
Perfetto.
I don't know if it's 1 million, 10 million on 10 million minus 1, but we'll see. I think it's.
But this is already excluded. Do you want to exclude another one?
That is already excluded. No, if it's but 0 is included.
0 is included.
Do from 1 to 10 million. To 10
okay.
Million. Okay, so we exclude one of the 2 ends. Perfect. At this point, outside of the loop, we can do let mutable current equal to the first element.
The first outside of the loop, right?
Current is the first element. We have it. Yeah, we have first.
So we have first, yes. And in the loop, we need to pop 3 after current.
Yeah.
Right.
So now let
pick. What did we call it?
Pick it up. Okay. Is equal to our list dot pop
3 after current.
Yeah. Now we have a free element.
Now we need to find the target.
The target. So now we have to decrement current by 1. If
so
it
let
is
mute target equal current minus 1.
Yeah. If target is in the free that we popped out, we have to decrement it again.
Yes, so this is basically while target
we We can do picked up contains.
Yeah,
Does
not picked
no,
up.
while true, not while it contains.
Oh yeah, you're right. Sorry.
Contains
Contains
reference.
target.
Yeah. We have to do target minus equal 1. Minus.
But if it is 0, we need to wrap around.
Yeah.
Right?
Also after the... No, we don't have... we don't need cure. It's just target minus minus. Just decrement target.
Yes, sorry.
Okay. We have to do, if target is 0, target is 1 million, there, and also after line 111.
And target is equal to 1 million.
We have to do this if even after line 111. So copy it. We can refactor it better. At this point, we have our target. Now we have to do list push free at the target.
Now we do list dot push 3 after target.
And there are our 3 picked up
elements is picked up.
Exactly. What do we have to return? Now current is list next current. We have to update current.
Yes, at the end of the loop. So current is equal list dot next current.
Of current. On line 126, we have to return list next one multiplied list next. Okay, we have to take the 2 numbers after 1. How do we do that?
Okay, let first list after 1 is equal list
next one,
and then let second
the one
after 1 is equal list dot next first after 1, and we return the 2 of them multiplied.
And casted as U64. I don't know. We need it. Can it overflow? What are we returning in the function?
We are returning a usides, but that could fail in different architectures.
That could fail because if we have usides that use 32, we can overflow easily multiplying U32 together. So, will it work? I hope so.
Do we have the test tube? We do.
Yeah,
there you go.
Down there.
It didn't work. Oh my god. When did it panic? Index out of bound. The len is 2, but the index is 2. Client list line 16.
I understand it. Outside of the loop, we have to locate at least 10 locations. Is in our the library, I think, is not here.
Line 16 was this one.
Sorry, I don't see the screen for some reason. Okay, now I've seen it. Yeah. It's always the problem that our vector is not already populated. Line 12, do that 10 times before...
But why is this happening?
Because our input is 7, 5. And so we say, okay, data of 7 equal 5, but our data is not long 7 yet. In our test is working because we are 1, 2, 3, 4, 5,
Oh,
6.
yes.
If you go 6, 5, 2, 1, 3, it's going to fail even in our test. That is a mess. Do you know what? Instead of doing the push inside the loop, do a 4 underline in 0 to 1 million and 1 push. I understand that it's terrible, but it's just to fill the vector.
Yeah, that's super annoying. I wonder if there is with capacity.
With filled capacity. I don't know how to say that.
I'm just curious. If there is a vec, what do we get? Extend from within? I have no idea.
No, let's go with a dirty push.
Let's do with a dirty thing, and then if it works, we refactor next time. So
Yeah.
4_ in
0,
Zero.
dot 1,000,001.
we do
Data
data push.
push 0 and remove everything, all the other pushes. Now we don't need them anymore. This is why you can't allocate a fixed amount of memory. Come on. Now it's complaining the data is
Same item push. Oh, you can do vec size. Oh yeah, that's right. Okay, I didn't think about that. Thank you, Clippy. So we could basically do this, and it's pretty much the same thing that we are just doing.
oh, come on. And it's not going to explode in our face because of
because this is literally means you know that the size is this, and you need to fill it with 0, so it knows how to do all of that.
Perfect.
Cool. Let's see if that makes it up now. Test you where you are. There. It's probably gonna take a while, but not so long.
No, not so long.
3 seconds is good.
Because we're not in the release, we are in the bug, so it's 10 times slower.
Okay,
cool.
So I think that for today we have covered more than 1 hour. So
yeah,
probably I'm
the
gonna
logic
commit here.
Yes. These can be improved with the game state for part 2. This is slightly different from part 1. We can redo part 1 with this approach, but part 1 is 10 numbers. Make no sense probably to do this complication for part 1.
Yeah, exactly.
Probably it's going to be slower than how it's implemented right now, probably. But in any case, let's wrap it up. You can find the recording on YouTube. The link is in the Twitch in the about section. If you're watching this on YouTube, we do live streaming every Monday at 5 p.m. UTC. Make sure to check the Twitch link in the YouTube description. Give us a follow, thumbs up, also thumbs down if you want. Now nobody will see it anymore. Feel free to leave us a comment and open PRs. The repository of the code is on GitHub at this. Let's try again. At this location, everything is well accepted. We are trying to learn Rust. Don't expect our solution to be the cleanest one, this one in particular. If you know better ways of doing stuff, let us know. Thank you for the suggestion, the collaboration. And are we going to raid somebody?
We are going to raid AWS because it's the only one I know that I see online. So
perfect.
I hope that they are doing something interesting for you. Talking about AWS Glue, so maybe it's interesting.
Probably. Thank you. Bye, and see you next time.
Bye.
Bye.